Okay, I cannot believe we are on the last unit of videos. Wow, it's been a while. Pat on the neck for all of us. We've gone far, kids. And now we are finally on the last unit, which is polars and parametrics. So in this video, I'm going to quickly review what parametrics means. If you guys forgot from your pre-calculus class, and then I'm going to talk about how to find tangent lines to parametrics and be able to find the arc length of parametrics as well. So to begin, let's start talking about what a parametric is. So if you guys remember from your pre-calc class, parametric is when you have two lines that have t's in them, and that means that there's a motion. So let's do x equals sine of 2t and y equals cosine of t. I don't know, I made those up. In parametrics, there is a third variable, and remember how you would eliminate the parameter to get the original equation? Well, in calculus, we don't need to do as much work, actually. So let's say right here that the question said, find the tangent line to the graph when t equals, we'll say, pi over 4. I'm making this problem up right now. Well, the first step we're going to do is we're going to take the derivative of both of these. Now remember, because it's x and there's t's in here, we'll be taking the derivative of x in respect to t. So it would be dx dt equals 2 cosine of 2 theta, or not theta, I'm sorry, 2t. Thetas will come later. Then we're going to find the dy dt, so we dy dt equals negative sine t. And then, well, if we want to find dy dx, because we want to find the tangent line on an xy plane, then we're going to take dy dt and multiply it by dt dx, because, as you can see, the t's will cancel out and you'll just get dy dx. So basically, you're going to take this one and divide it by this one, and you're going to end up with negative sine of t over 2 cosine of 2t. So now if you wanted to know what the tangent line would be when t equals pi over 4, you first want to get the slope, because this is dy dx. You want to know the slope. I'm just going to cover this for a second. Then dy dx when t equals pi over 4, you just plug in pi over 4 into here, so you get negative sine of pi over 4 over 2 cosine of 2 times pi over 4, so it's going to be pi over 2. Actually, that's going to cause some problems, isn't it? Maybe I should have thought this through. Okay, how about we do pi over 2 instead? That's not going to work, is it? Let's do pi over 3, okay? We'll make this even more messy than it already is. Sorry. If realize it's going to cause us to divide by 0. So, now we're doing pi over 3. Then negative sine of pi over 3 over 2 cosine of 2 pi over 3. And then you get the slope is negative, well, the sine of pi over 3 is negative 1/2. Well, it'd be 1/2 if it's negative, so negative 1/2. Then 2 times the cosine. The cosine of 2 pi over 3 is, wait, this is not 1/2. This is root 3 over 2. I think I get nervous in these videos or something. I just make more mistakes. Here is negative 1/2, so it would be negative 1. And the answer you get is root 3 over 2. Then, I'm going to erase this. To find then what the tangent line would be, we would plug in these values to get what the x and y point is going to be. So x would equal sine of 2 pi over 3, which would be negative 1/2. Y would equal cosine of pi over 3, which equals 1/2. Why do I keep doing that? This is positive root 3 over 2. This is embarrassing. Yeah. And then, so the answer of y minus 1/2 equals root 3 over 2, x minus root 3 over 2. And that would be the line that is tangent to this parametric equation when t equals pi over 3. So this unit is basically taking what we know before, and we're just going to expand it over to polars and parametrics. Last thing we're going to talk about in this video is arc length. Now, there was an arc length formula that you earlier in the year, but I'm just going to teach it right now. basically, we're going to go do the same equation, if I can remember it. Isn't it sine of 2t and y equals cosine of t, I think? Wasn't that it? Well, what if we wanted to find the arc length from when t, how about the arc length from t from 0 to pi over 2? I'm going to not calculate this, I'm just kind of going to set it up, and you can use a calculator to calculate this. But basically, we're going to use integrals. This was a concept that was in the rotation unit that was like 5 or 6 units ago. However, I don't think I made a video about it, or if I did, I'm forgetting. But basically, you can find arc length by using an integral. So what you're going to do, the formula is integral from t1 to t2, which will be 0 to pi over 2, times, or the square root of dx dt squared plus dy dt squared. Now this is actually an example of the Pythagorean theorem, but I'm not going to prove this right now. Basically, this is what the formula is. So in this case, to find what this one would be, you would go from 0 to pi over 2 square root of dx dt, which is 2 cosine 2t squared plus negative sine of t squared dt. And that would give you the arc length of this parametric equation from 0 to pi over 2.